If you have been following along with this tutorial, you will be up to this point where you have a loop that has run in an update draw and only contains scene as its only attribute, its only variable. Scene has a map of layers and a list of renderables that is defined inside globals here. The class, this also has our width and height, has our whole Raylib library. Our entity is as simple as a renderable who contains a transform component and a speed. Similarly, paddle and ball are separate objects that are an entity, and in loop we construct those. We have a player with the opponent and the ball. We can add them to the scene. We can also remove them from the scene. And the only thing that we have left to do is really, honestly, collision for an intermediate programmer. Because the fact is, if we have our paddle moving, then we know that we can have the ball moving. We don't have to move the ball and then be like, okay, now we check collision. Like, no, screw all that. All we have to do is check, really, collision. And then, score increase too, guys. Like, by this point, if you're able to follow this tutorial, understand what's going on, yeah, I mean, that's all we need. So, with that in mind, notice how in our math library we used a namespace and inline functions. And then over here in entity we had a component. And then we have our entity here and our paddles and whatnot. I'm actually going to come down here and we're going to make two, in a sense, we really only need one type of collision, and at the same time, I want to do three. I'll give you guys a couple bonuses here. So first, we're going to do radial collision. Now, a radial collision detection in this case is going to take things easier. I think we're just going to use a transform component. And we're going to have a left-hand side and a right-hand side here. And this is going to return of type bool, true or false. So the first thing we need is a addition of a radii. So left-hand side radius plus our right-hand side's radius. That's going to be our sum. And then we need the magnitude, or rather the distance between them. So in this case, magnitude is a float. It's magnitude. We can use our get magnitude function here. We use the left-hand side's position, our right-hand side's position. And then simply, we can say if the sum of our radius is greater than or equal to our magnitude, we can return true. Otherwise, we can return false. This is a radial collision. Very, very simple. Just kind of show here. Just to kind of mess with some things real quick. We'll put is player here under entity, and then over here I'm going to do oh my, I suppose a couple things. Bear with me, guys. You may have seen me rewrite a couple things in this tutorial, but I just kind of want to showcase this radial collision. It's a common theme here. If I write something, I definitely do want to showcase it working and not just go, yeah, it works, and then you guys go, hey Brett, you're wrong. It's definitely okay if I am, but definitely want to do best at not giving junk code. So here we're going to have a full-on movement. It's going to be an X and a -1. This is going to be an X of +1 with D here. And it's mad at me because it didn't know where those variables were coming from. And similarly here, ball update, and we know that we want to call our entities update. But before that, we want to call our fixed update like so. Seems fine and dandy. Come back to loop here. I'm going to say ball is now this. Like so. And just to have things similar, we're going to do it like that. And then up here, and we'll have to use this step. All right, and I'm hoping when I show you guys this stuff, it's kind of showing you the scalability of this project here. So just to show, you know, we can make the ball the player, the ball can move, still uses the update here. It's going to render as a circle. And if we come over back to here, we made this an inline function. And it takes in the transform components of the things, you know? And there's going to be kind of a weird way to go about this, just because everything belongs as a iRenderable, which is not necessarily great in some ways. In other ways, it's fine. I would prefer maybe to have it as an entity at the end of the day, but I digress. As you build things, guys, you'll never have that perfect system. It's just kind of the way it goes. I'm just going to save here, hit make, and run. Should have another ball. Looks like we have 2 balls here. I would say that is because in entity, in this ball's version, this here was probably uninitialized, as in when it lives inside entity here. Yeah, see how it doesn't start with false? That's because it doesn't start with false, its behavior is undefined. So over here in entity, it would probably be best to just do that overall. And then inside the ball constructor, we could go like this and call our entity constructor. Similarly, this is something that should have been called for paddle as well, like so. And then come back here. So now we have a ball. And what we want to test is when the balls touch, is there actual collision? Well, there's one thing I kind of like to do. It's not necessarily the best collision detection system in the world, but it is a decent collision detection system. So we're just gonna have last position here as well. And in update here, we're actually not gonna touch Jinx. So coming over back to the plot. Okay, so here in Entity we have a radial collision. We take and transform components here, yada yada yada, you know, and this is going to return true or false, and we need to pass in this data. So over here in loop, before we update, we could say something like, hey, radial collision, and then we need that left-hand side, that right-hand side. We know relatively that that was number 2 and number 0. I mean, in something like this could be fine to do. Now, something that is a little bit more verbose, you'd want some getters, better ownership with smart pointers. I'm not going to go over that in this system here. So this would be a .@0 guy, and then we want 2 as well. And here I'm going to say ball pointer player is this guy. Ball pointer ball is the other guy. And for radial collision, we'll say, hey, player and ball's opponent here. We're going to check if this is true. So if this happens, and then check, you know, when it doesn't happen. In this case, I'm going to say player dot t component dot last position is equal to the player dot component dot position. And if it happens, we're going to say the opposite. My position is going to become my last position. So we got some stuff here. Yes, we do. Okay. This is something that, you know, is a debatable thing to do. So just keep in mind that what I do, I'm not at all saying this is the best practice to do, but I am saying I'm going to do it. So what I'm going to say here is my player, and we're going to dynamically cast ball to 10 point. And then similarly with the other guy. So let's see what happens when they bump each other. You know, and it's not perfect collision, guys. Like, it's not separating axis theorem. It's not, you know, the best. Notice, like, sliding's a little funky. But the point is, for a lot of collision, really all you need to do is have if something happens, set its position to where it was, and if it doesn't, go ahead and keep track of that position. Again, if you are a C++ entrepreneur, connoisseur, someone who likes to code, you might go, oh, dynamic casting's bad, all these things. And especially like every frame, right? Like, fuck, you're casting every frame. That is horrible. I mean, yeah. Honestly, not great. Not great. There's different ways to go about this as well. For example, here in Scene, we have this renderables. It's an iRenderable pointer. That cast is kind of an issue. I mean, one way to go about this that I wouldn't necessarily say like is the end-all be-all solution here, but it definitely is a better solution than casting like that. We could say entity for here, technically. Technically, I think you could technically keep those as iRenderables. Maybe. But, you know, if we change those to entity here, not a whole lot changes. In fact, really don't think it matters a whole lot. And the nice thing here is kind of the scalability of our system. Because instead of dynamically casting to a ball and blah, 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 and whatever, and comparing those, technically, we should be able to do this now. Let's see what we got here. Could be because of that, to be honest. I know it's ugly looking. Just kind of see here. Oh. It's just kind of see here if what I'm thinking is correct before I go too far down the rabbit hole. So E2 E dot T comp dot position equals So update scene is saying it's kind of mad here. Let's take a look. That's the thing right there. That actually may have been a lot of the issue right there, to be very honest. Yeah, it looks like I got a couple things funky there. Back to loop. And that's the other thing there. We need the component value. Now, as we get a little deeper into this, we're going to have a little bit more debugging. So, redefinitions. Why do we have redef? So this is taking globals and mathlib. Scene is taking entity. Loop is also taking entity. Let's go like that. So yeah, you could fix that with Pragma once for the redefinition. I did probably the worst way, which was just like remove it overall. So yeah, just kind of keep that in mind. Now again, notice we're setting this variable every frame as well. That's not great. So just wanted to make sure I was doing that correctly before kind of continuing down a wrong path. Now again, it's going to look kind of gross here. Like that, you know, that doesn't necessarily look the greatest. E2 is not clear in the scope. Yeah, that's definitely an issue there. Okay, let's try to write that correctly this time. Okay, so just kind of going along. I'm going to compile there just to see, like, am I crazy? What is going on there? Yeah, I mean, it is overall harder to write, obviously, when it's a long thing like that. I'm going to try it one last time to write it correctly in this case. So my scene has a renderables list, and from my layers in my entity, I want to access 0. from 0, I want the component, and I want that component for number 2. I want to file, save, make clean, clear, and make. Does that compile? Okay, that compiles. So if that is not the case, I want my last position to equal position. Otherwise, I want this whole thing here. Position is that, last position is this. Save, make clean, clear, and make. Alright, certainly harder to write when it's a long thing like that, but now we're not saving a variable, now we're not casting a dynamic cast. None of our systems broke just because we told this to be an entity instead of iRenderable. It's even more arguable in the fact of, for globals here, do we need that? We absolutely do not need that. And it definitely takes away a unnecessary layer of abstraction in this case. You know, there's many ways to skin a cat, as you've seen, but yeah, that is Radial Collision. Now on to the next.